Okay, lesson 5. Lesson 5 on Unit 1. It's about operations on the real numbers. Of course, here operations means the mathematical operations like addition, subtraction, multiplication, multiplication, division. So first point, we will start with the addition process. So first, addition. Addition means to add two real numbers. Like, for example, if I want to add 2 square root of 5 plus 3 square root of 5. Here, guys, we will consider that square root of 5 like variable. It's exactly like 2x plus 3x. So simply we will say that it will equal 5x, correct? Also here, 2 square root of 5 plus 3 square root of 5, we will add 2 plus 3, so it will equal 5 square root of 5. And of course, to add the square roots or the cubic roots, it has to be the same. I mean, if it's 2 square root of 3 plus 2 square root of 5, for example. So here we can't add the two numbers because they are totally different. Square root of 3, square root of 5. But on the first example, square root of 5 is the same like square root of 5. So here, add this number and this number, or in other words, the coefficients. So it will equal 2 plus 3 means 5, and then square root of 5. It's like adding the algebraic expressions exactly like this. 3x plus 2x. Okay, simply this one is 5x. But if it's like that, 2x plus 3y, can we add these two terms? Of course, no, because they are different. Also the same in the square root and the cubic root. Now, if there is 2 square root of 3 plus 5 square root of 3, so simply this one will equal 2 plus 5 means a 7 square root of 3. Okay? But guys, we can't add 2 square root of 3 and 3 square root of 7. We can't add these two numbers because this one is square root of 3, this one is square root of 7. It's totally different, like adding x and y. So it has to be the same exactly. Okay?
Okay.
Then the next point in this lesson, okay, is to know the properties of addition of the real numbers. As usual, guys, any set of numbers, okay, has some special properties. So the properties of addition, as we studied before on all sets which we studied in the last years, the first property is the closure property. Okay, closure property means the sum of any two real numbers will equal real number. So this means real number plus real number equal real number. That's why we said that the real numbers is closed under addition process. Okay, because simply real number plus real number, of course, will equal real number. Okay, so that was the first process. So for example, real number plus another real number, it will equal real number. Now here the coefficient is 1. Okay, and here's 3. So 1 plus 3, 4, and then write down square root of 5. So square root of 5 plus 3 square root of 5, it will equal 4 square root of 5. So this one is the first property. It's the closure property. The property number 2 It's the commutative property. Commutative property means we are adding two elements, and so that it's possible to replace, okay, each one instead of the other. I mean, before we said that 2 plus 3 equal 3 plus 2, correct? Because in the two cases, it will equal 5. Okay, guys? So also here, in our case, if I'm going to add 3 square root of 2 plus 4 square root of 2, okay, it will equal the same like 4 square root of 2 plus 3 square root of 2. In the two cases, it will equal what? Of course, 7 square root of 2. Okay? So the same result, 3 plus 4, 7 square root of 2. 4 plus 3, 7 square root of 2. So also the addition is commutative. Okay.
Mister, can you explain
The next step. Yes, sure. So commutative means replacing the elements with each other. So simply, again, commutative means it's like 2 plus 3. Of course, it's will equal 3 plus 2. No difference. In the two cases, it will equal 5. It will be also the same and the roots, like 2 square root of 3 plus 3 square root of 3, it will equal 5 square root of 3, or 3 square root of 3 plus 2 square root of 3 also equal 5 square root of 3. So replacement of the location of the number will never change the result. In addition, okay?
Okay.
Okay, great. Then now the next property, it's about the associative property. Then now, what about the associative property? Actually, we studied that property before, okay? It's about grouping numbers. I mean to that, if there are 3 numbers or more than 3 numbers, we can group each 2 numbers together and then sum each 2 separately, then add the result to the third, like this. Simple example without roots and that stuff, okay? If it's 2 or 3 plus 2 plus 5. So associative property, we can group 3 plus 2 first, then add 5. Or 3 first, then plus 2 plus 5. In all cases, the result will equal 10. Right, guys? 3 plus 2 plus 5, 10. 3 plus 2, 5 plus 5, 10. 3 plus 2 plus 5, 7 plus 3, 10. Correct?
Correct.
So associative property is to group 2 numbers, whatever, the first 2, the second 2. This will be depending on the numbers on the questions. Okay, let's take an example by using the roots like this. If the questions like that, square root of 3 plus 2 square root of 3 plus 5 square root of 3. Actually, this one simply will equal square root of 3 plus 2 square root of 3 between 2 brackets, then plus 5 square root of 3. It will be the same result. Or otherwise, it will equal square root of 3 separately like this, then plus, group the second 2 numbers, 2 square root of 3 plus 5 square root of 3. In all cases, it will equal 1 plus 2, 3 plus 5, 8 square root of 3. Here also, 3 square root of 3 plus 5, 8. Here, 7 square root of 3 plus 1, 8. So that was the associative property. Is it clear?
Yeah. Yes.
Okay. That sounds very good. Then the next property, it's about the additive neutral. Additive neutral, actually, it's a constant in all sets which we studied before and which we will study in the future. Additive neutral, its name was additive neutral. Or in other words, it was additive identity. Okay, so simply it's a neutral. So this means what? It means it will never change the result. So I'm talking about 0, of course. So 2 plus 0 will equal 2, nothing changed. Square root of 5 plus 0 equal square root of 5, nothing changed. Why? Because it's a neutral. Okay, so what will be the additive neutral element? It's 0. Okay, guys, are we clear till this point?
Yeah.
Okay, that's great, actually. The next point in the property is it's about the additive inverse. Additive inverse. Okay. Now, next point, additive inverse. Okay, additive inverse. All of us knows that the additive inverse before. We studied that one before on the integers, on the natural numbers, and so on. So additive inverse, if the number is 3, so the additive inverse, just to change the sign, -3. If it was 5, -5. If it was -2, 2. Anyways, the sum of the number plus its additive inverse equal 0. Okay, and by the way, additive inverse of 0 is also 0. Okay, that was very old. Okay, then what about the new topic? And the real numbers here and the roots. Concentrate well. If there is a number like this, 2 plus square root of 5, and I want to get the additive inverse of this one. So do I suppose to change the sign of 2 only, or square root of 5 only, or both? By the way, guys, concentrate very well with me in this point. We just said that the number plus additive inverse equal 0. So now I'm looking for a number to add it to this one so that it will equal 0. So simply in this case, I supposed to change the 2 signs. So this means -2 minus square root of 5. Okay, so now if I'm going to add the 2 numbers like 2 minus 2, it's a 0. Square root of 5 minus square root of 5, 0. So the additive inverse of the real number, okay, whatever the number of terms, 7 minus square root of 7, additive inverse, -7 plus square root of 7. So simply I change it. This sign, it was positive, now it becomes a negative. This sign, it was negative, now it becomes positive. Okay, guys, clear?
Okay.
Okay, another
Clear,
example. Another example of the numbers like this, 3 minus the square root of 2. So simply, it's a -3 plus square root of 2. Okay. Also, guys, I can change the order for this number. So the additive inverse for the first number is this one. Also, I can write it like this, square root of 2 minus 3. I just changed the order with the same signs. I mean to here, square root of 2 was positive and still positive, but -3 was negative and now also still negative. Just I rearrange the terms. So this means a -3 plus a square root of 2 equal square root of 2 minus 3. So the same exactly. And a simple example like this, -3 plus 5. Actually, this one is 5 minus 3. Am I correct?
Yeah.
I just get this number in the beginning and it will be 5 minus the 3. Nothing will change here, correct? Again, I'll get back to the additive inverse. If the number concentrate well, 2 plus square root of 5. Now, additive inverse, -2 minus square root of 5. Okay?
Okay.
Okay, great. So that was about the addition operation. Now the next point, it's about the multiplication. Okay, what's the difference between addition and the multiplication? Of course, nothing. I mean that if it was 2 square root of 3 minus square root of 3, simply it was 2x minus x, so it will equal x. Instead of addition, I'm going to subtract the coefficients. 2 minus 1 equal 1. And by default, we will not write 1, so it will equal x. Here, 2 square root of x3 minus square root of 3. Square root of 3 only. So, nothing new till now, right?
Yeah.
Okay. About the properties of addition, actually, the properties of subtraction. Actually, subtraction process is very poor in the property. So, the only property that we can apply on the subtraction is the closure property. Okay? So that real number minus real number equal real number. Okay. But do you think that subtraction is commutative? No. We said in addition, 2 plus 3 equal 3 plus 2. In the two cases equal 5. But 2 minus 3 not equal 3 minus 2. This one is -1, but this one is 1. Right? So it's not commutative. Also not associative. Okay? So addition only, closure, commutative, associative, and so on. But subtraction has no property at all. Not commutative, not associative, and so on. Okay, guys? Let's solve some questions on how to add real numbers and subtract the real numbers. Okay, the first question. Square root of 7 plus square root of 7 equal dots. Okay, now this question, it's like x plus x. So 2x. So 7 square root of 7 is square root of 7, 2 square root of 7. Just add the number before the square root and then write down the square root. Another one. 2 square root of 2 minus 3 square root of 2 equal 2 minus 3 negative 1 square root of 2. Okay, clear?
Clear.
Okay, another question. 4 plus square root of 3 minus 7 minus square root of 3. Now, guys, please to remember addition of like terms. So simply, I'm going to add the whole numbers. 4 minus 7, negative 3. Square root of 3 minus square root of 3, it's a 0, so it will equal negative 3. Okay?
Okay.
Okay. Another question. The next question, if x equal 9 square root of 5 and y equal 5 square root of 3, then x minus y equal. Here, x minus y, x 9 square root of 5 minus y 5 square root of 3. Actually, it will equal this result only. I can't simplify it. Why? Because this one is square root of 5, this one is square root of 3. Different, correct? So I'll keep it like this. Okay? By the way,
Okay.
guys, never add or subtract different roots. Never. It's like adding or subtracting x plus y or x minus y. Of course, we can't do that. Okay?
Okay, Mister.
Okay. Also, one confusing question like that, which I solved at the first. Square root of 7 plus square root of 7. Never say that is square root of 14. Fatal mistake. Here 1, here 1.
Square root of 7.
2 square root of 7. Correct?
Correct. Yeah.
Okay. One more question. Additive inverse. Of square root of 7 minus square root of 5. Then I will write down some choices. Negative square root of 7 minus square root of 5. Square root of 7 plus square root of 5. Square root of 5 minus square root of 7. Square root of 7 minus square root of 5. Okay. Now, I don't care about the results. First, I will check the number. It's this one. The additive inverse means negative square root of 7 plus square root of 5. But actually, it's not exist here. Then change this form, replace the numbers. So square root of 5 minus square root of 7. Correct? I just replaced this numbers. I'll show you like this. This one will becomes on the beginning like that. I just take this one on the first here. So it becomes a square root of 5 minus a square root of 7. Now, that's a choice, of course, number 3. Okay, guys?
Can you explain it again?
Again, sure. First, how to get the additive inverse of the number? Additive inverse of the number, just to change the sign of the numbers. So the first one was positive, so it will becomes a negative square root of 7. The second one was negative, so it becomes a positive square root of 5. So this is the additive inverse. Do we have this one in the choices? Actually, no. Then, what do I suppose to do now? Here, as I said before, negative 2 plus 3, it means 3 minus 2. Am I correct? I just shifted this number here, so it becomes a 3 minus 2. Correct, guys?
Correct.
So the same, I'm going to do the same here. Shift this one in the beginning, so it will become the square root of 5 minus the square root of 7. That's a choice. Okay?
Okay.
Okay.
Now it becomes clear, guys, or not yet?
No, it's clear.
Clear.
Okay, great. Another question. There is a question like this. If square root of 2 plus x equal 0, then x minus square root of 2 equals dots. The first choice, 0. Second one, negative square root of 2. Then negative 2 square root of 2. Then 2 square root of 2. Okay. Here I want to get x minus square root of 2. Okay. My question, it's a simple equation, guys. X will equal what from this equation? Shift this one to the right, change the sign. It was positive, so now it will becomes a negative. So x equal negative square root of 2. Are we correct till now?
Yes.
Okay, that sounds very good. Now, x, it's a negative square root of 2, negative square root of 2 minus square root of 2, so negative 2 square root of 2. Okay?
Okay.
Okay.
Mr. Can you repeat the question?
Again, sure, yes. Again, this question one more time. Concentrate very well. It's a given in the question that square root of 2 plus x equals 0. Now, I'm going to get the value of x. X will equal, I'll solve it like equation, just shift the number to the other side. Don't forget to change the sign. So x will equal negative square root of 2. Correct?
Correct.
Now, I want to get x minus square root of 2. What will be the value of x? It's a negative square root of 2. So negative square root of 2 minus square root of 2. So here negative 1, here minus 1. So negative 2 square root of 2. It's like negative x minus x and negative 2x. Correct, guys?
Correct.
Now this question is also clear.
Yes.
Okay. Let's solve another question. The next question, actually, it's about the additive inverse. Here, I'm going to write some numbers, and then we want to find additive inverse. First one, square root of 2. Second one, negative cubic root of 5. Then square root of 2 plus square root of 7. Cubic root of 5 minus 3. Negative square root of 6 minus cubic root of 7. Okay, now write down the additive inverse. The first number, additive inverse, change the sign of all numbers. Negative square root of 2. That's it. Change the sign. Cubic root of 5.
Cubic root of
Change the
5.
sign. Negative square root of 2 minus square root of 7. Change the sign. Negative cubic root of 5 plus 3. Square root of 6 plus cubic root of 7. I just change the signs simply. That one was positive, becomes a negative. Negative, positive. Positive, negative, positive, negative. Positive, negative, negative, positive. Negative, negative, positive, positive. That's it. Very simple process, right?
Right.
Any questions related to this point? The additive inverse?
No, thanks.
No, thanks.
Okay, great. The next question before starting the second topic, which is about, actually, we finished addition and subtraction. Then the remaining topic, it's about multiplication and division. Okay. But actually, there is one question remaining related to addition and subtraction. The question is like this. Simplify. 2 plus 2 square root of 7 minus 1 minus 5 square root of 7. Okay, it's very easy. Number, 2 minus 1, 1. 2 square root of 7 minus 5 square root of 7. 2 minus 5 minus 3 square root of 7. I'm done. Finished. Okay?
Okay, Miss.
Okay.
Okay. One more question. Concentrate on the next one. 3 square root of 5 plus square root of 3 minus 3 square root of 5 plus 5 square root of 3. Okay, it seems like it's the same numbers, but actually it's not. Just for confusing us. Okay. Only I care about the square root of 5 and 5. 3 and 3. So now, add or subtract the like terms. This one, 3 square root of 5 minus 3 square root of 5. Actually, 0. Right?
Right. Yeah.
Now, the next two terms. Square root of 3 plus 5 square root of 3. So 1 square root of 3 plus 5, so 6 square root of 3, also finished. I think it's a very easy topic, right?
Right.
Right.
Yes.
Okay, great, guys, great. Okay. Okay, now the second point in this lesson, it's about the multiplication. Actually, the multiplication process is very easy. Like now, if I want to multiply 3 times 2x, now simply it will equal 6x. If it's 3 times 2 square root of 3, okay, multiply the coefficient times the coefficient, so 6 square root of 3. One more example. 2x times 3x. In this case, there is a little bit difference. 2 times 3, 6. X times x, x squared. On the same side, also here, the roots. If the two numbers consists of roots like this, 2 square root of 2 times 3 square root of 8. So simply here, 2 times 3 equals 6. Square root of 2 times the square root of 8 means the square root of 16. Okay, my question, square root of 16 means equal what? 4 times this number. So it will equal 24, right?
Right.
Again. 2 times 5 square root of 2. Simply multiply 2 and 5. 10 square root of 2. But if it's 2 square root of 2 times 3 square root of 8. Okay, so now 2 times 3 means 6. Then square root of 2 times the square root of 8. 2 times 8, 16. Square root of 16, there is no square root of 16, so it will equal.
4.
Sorry, why there is no square root of 16? It will equal 4, of course, right? So now it's a 6 times 4, which means 24. Okay?
Okay.
Another example. -2 times 3 square root of 7. So now, simple, multiply -2 times the 3, it's a -6, and then drop down this one, square root of 7. Okay. If it's 4 square root of 2 times square root of 2, this means 4 square root of 4. Now, square root of 4 means 2. So 4 times 2, which means 8. Okay, guys? Are we clear to this question?
Yes.
Okay, another question like that. -2 square root of 7 times the square 4 square root of 7. Okay, nothing different. -2 times the 4, -8. Square root of 7 times the square root of 7. Actually, it's a 7 directly, right?
Right.
Because the square root of number times itself equal the number. Square root of 2 times the square root of 2 equal 2. Because simply this one is square root of 4, which means it's 2. Correct?
Right.
Or in other words, we can say that in the top on this question, -8 square root of 49, which means 49 square root means a 7, right? So it will equal the same result. Correct, guys? So it will equal
Correct.
6. Now multiplication is clear. Actually, that was the first point in the multiplication. The second point, it's about the properties. Okay? Any questions on this point?
No, thanks.
Okay. The next point of the properties, as usual, closure. Okay. The product of any two real numbers equal real number. Real number times real number equal real number. Simply 2 square root of 2 times 3 square root of 7 equal 6 square root of 14. Real. Correct?
Correct.
Okay. The second property, as usual, commutative. The third, associative. Okay, then second first, commutative. Two square root of 3 times 4 square root of 5. Actually, it will equal 4 square root of 5 times the square root of 3. It's the same in the two cases, 8 square root of 15. right?
Right.
Okay. What about the associative? It's about grouping two numbers out of three or more than three numbers, like this. If the question is 2 square root of 7 times 4 square root of 7 times square root of 7, it will equal, we can group the first two, 2 square root of 7 times the 4 square root of 7, then times the square root of 7, or the first term separately times 4 square root of 7 times square root of 7. Finally, it will give the same result. 2 times 4 equal 8. Correct?
Correct.
Okay. Square root of 7 times the square root of 7 equals 7. 8 times 7, 56 times the square root of 7, 56 square root of 7. Again, how did I got this result? Step by step. The first two terms. 2 times 4, it's 8. Square root of 7 times itself, it's 7. So this one is 56 times square root of 7. So 56 square root of 7. Correct?
Correct.
Okay. By the way, 2
Can you say
times
it again?
square root. Of course, 2 times the square root of 6 equal 2 square root of 6. Not equal a square root of 12. But square root of 6 or square root of 2 times the square root of 6, of course, equal square root of 12. Take care. We will multiply the two numbers if both square roots. But if one whole number square root 2 here times this one. So it will equal 2 square root of 6. Okay, guys?
Okay.
Okay. Again, that question one more time on the top. Here, how to multiply these numbers. It's exactly like multiplication of two numbers. First, I will multiply these two numbers. 2 times 4, 8. Square root of 7 times the square root of 7 means 7 times the square root of 7. So 8 times 7, 56 square root of 7. Clear, guys?
Clear.
Any questions?
No, thanks.
Okay. Now let's shift to the second point or the next one. There was an addition, there was additive neutral. Actually, in multiplication also, there is neutral. Its name is multiplicative neutral. So I will try to think about it. What do you think? We said that neutral will never change the number. In addition, it was 0. So in multiplication, very good.
1.
Actually, it's 1. So if you multiply any number times 1, it will equal the same number. Square root of 5 times 1, it's a square root of 5. Nothing can change. That's why we said that 1 is the multiplicative neutral. Okay, guys?
Okay. Okay.
So the additive neutral element, 0. Multiplicative neutral element, 1. Okay?
Okay.
Okay. The next property, it's the multiplicative inverse. Okay. Multiplicative inverse. We studied that point before also. If the number is 2 over 3, so multiplicative inverse is 3 over 2. If it was negative 4 over 7, so negative 7 over 4. So I just flip the number. The numerator becomes a denominator, and the denominator becomes numerator. Correct?
Right.
That was the main concept for the multiplicative inverse. Okay. And also there is one more point. What's that point? Actually, the product of the number and its multiplicative inverse equal 1. And That's why 0 has no multiplicative inverse. Because there is no number, we will multiply it by 0 to get 1, of course. Or in other words, it's a 0 over number. So if we will change it, it will become number over 0. Number, it's not defined. It's meaningless. Division by 0 is not possible. So the only number that has no multiplicative inverse is 0. Okay?
Okay.
Okay. Now, guys, the same
مستر في صوت
concept.
حد فتح المايك.
Okay, I will switch off this microphones. Okay. Now the same concept on the square roots. Now my question, if there is square root of 3, what do you think about the multiplicative inverse? This one, of course, over 1. So it's 1 over square root of 3. Correct? If it's a square root of 2 over
Correct.
5. So 5 over square root of 2. Try to multiply the two numbers. You will find that the result equal 1. Okay? The multiplicative inverse of 1 is itself 1. The multiplicative inverse of -1 also itself -1. Correct, guys?
Correct.
And the only element that has no multiplicative inverse
Zero.
is 0. Okay. That was all the properties of multiplication. Now, what about division? Actually, division also, it's like subtraction, has no properties at all, except it's only closure or closed. But division is not commutative, is not associative, and so on. Why not commutative? Because commutative, it's like 2 times 3 equal 3 times 2. But simply in division, 6 divide 2 not equal 2 divide 6, of course. This one equal 3, this one equal 1/3. Totally different. Okay?
Okay.
Okay. Now, guys, I'm going to solve some questions related to multiplication and the division. By the way, what about the division process? Multiplication is very simple. If I'm going to multiply 1 over 2 times 2 over 3, so simply you can say that it will equal 2 over 6, right?
Right.
Then what about 1 over 2 divided by 2 over 3? You will say that it will equal 1 over 2. Change the division into multiplication. Get the reciprocal of the number or flip the number, so it will equal the 3 over 4.
3 over 4.
Exactly. The same concept also here. So let's solve some questions related to multiplication and division. The first question. Find the result. Square root of 5 over 5 times 4 square root of 5 over 12 square root of 2 divided by 1 over 3 square root of 2. Okay. Of course, as we know, if there is more than one process in the question, so we will follow the rule of the order of the processes. Multiplication and the division has no priority, so we will start from left to right. So if the first one is multiplication, then go ahead and start with the multiplication process. Or if it was the division, so start with the division. But the preference between addition and subtraction and division and multiplication. So here, first step, I'm going to multiply these two terms. Okay. Numerator times the numerator, like fractions exactly. So 4 times the square root of 5 means it's 4 times
24,
square root of 5.
25.
Square root of 5 means 5 over 5 times 12, it's a 60 square root of 2 divided by 1 over 3 square root of 2. So it's a 20 over 60 square root of 2. Now, the division process. change a division into multiplication. Flip the number 3 square root of 2 over 1. Now multiply. Simply, guys, there is a square root of 2 here and here, so we can simplify both of them. Now the question will equal 60 over
Over
60,
60 equal 1.
which means 1. I'm done. Clear, guys?
Yes, يا مستر.
Clear. This question is clear?
Yeah.
Yes, يا مستر.
مستر ممكن بس حضرتك تعملها تاني.
Again. First, I will start with the multiplication process. So here we will multiply the numerator times the denominator. So 5 square root of 5 times 4 square root of 5 means 4 times square root of 5 times the square root of 5 means 5. Correct? Over 5 times 12 the square root of 2. It's a 60 because I'm multiplying 5 times 12. Square root of 2. Division, change it into multiplication. Flip the number 3 square root of 2 over 1. Now you can terminate square root of 2 with the square root of 2. 4 times 5, 20 times 3, 60 over 60 times 1 equals 60. So 1. Okay? Now it becomes clear, guys, or not yet?
Yes. Clear.
Okay, great. Actually, the next question, there's another type of questions, okay? Let's solve this one. Write the following. Such that denominator is integer. The first number 9 over square root of 3. So the question is required to change the form of the denominator, and instead of square root of 3 to becomes integer. Okay. If there is a square root on the denominator to change the form of the number, so simply this one will be 3 if I'm going to multiply it by square root of 3 over square root of 3. So the denominator will equal 3 and the numerator 9 square root of 3. So again. Concentrate very well. The number is 9 over square root of 3. So whenever you see a square root on the denominator, times square root of 3 over square root of 3. Now, numerator 9 square root of 3, denominator 3. Now simplify 9 divide 3, so 3 square root of 3. That's it. The denominator now is integer, of course. It's over 1, right? Is it clear, guys?
Yes.
Yes.
Okay, another question. Like this exactly. If the number is -3 over square root of 2. So to change this form of the number so that the denominator becomes an integer, we have to multiply it by what? Square root of 2 over square root of 2. So numerator -3 square root of 2 over 2. Done. Correct? Now
Correct.
denominator is integer or not? Integer, of course. It's a 2. Okay. Another one. Five over 3 square root of 5. Okay. Now I multiply this number by square root of 5. So square root of 5 over square root of 5. So this means it will equal numerator 5 square root of 5 over 3 times Square root of 5 times itself, 5. Now you can simplify, terminate 5 and 5. Square root of 5 over 3. That's it. Now this type of questions is clear, guys?
Yes.
Yes, master.
So
Yes.
if the denominator is a square root, so simply multiply the number. If the denominator is square root of 7, so multiply the number by square root of 7 over square root of 7. Okay?
Okay.
تمام.
Okay, another question. Multiplicative inverse of square root of 5 over 10. The choice is square root of 10, square root of 5, 2 square root of 5, negative 2 square root of 5. Multiplicative inverse means the reciprocal of the number. So simply I have to flip the number. It will becomes a 10 over square root of 5. Do we have this one here? No. Then what will be the next step? Change the form of this number. Multiplied by what? Huh?
Square root 5.
So 10 square root of 5 over 5. Simplify. 10 divide 5 means 2 square root of 5. Where is that one?
The third one.
Okay?
Okay.
Okay.
Okay, great. The next question. Additive inverse. Additive inverse of 7 over square root of 7. And the choices are square root of 7 over 7, or 7, or negative square root of 7, or negative 7. Okay. Actually, here we said that in the additive inverse, we will only change the sign. So simply this one will be negative 7 over square root of 7. But actually, it's not here. So simply change the form of the number first by multiplying the number by square root of 7 over square root of 7. So it will equal 7 square root of 7 over 7. Now simplify, terminate 7 and 7, it will equal square root of 7. Then what will be the additive inverse of square root of 7?
Negative square root of 7.
Very good. Okay?
Okay.
This one is also clear to all of us?
Yes.
sir.
Here.
Okay, great. The next question. Multiplicative inverse of 3 square root of 2 over 4, and the given results was 4 square root of 2, or 2 square root of 2, or square root of 2 only, or 4 over 3 square root of 2. What do you think? It's the multiplicative inverse. So simply we will just flip the number.
The last one.
4 over 3 square root of 2. Okay. But if the question is coming like this, multiplicative inverse of this number equal number over 3, and here dots like that. So if I'm going to flip the number, it will equal 4 over 3 square root of 2, but I need the
4 times
denominator.
square root of 2.
Times
عشان هنعمل الاتنين.
Exactly. So in this case, simplify the number. So this means times square root of 2 over square root
over
of 2.
square root of
So it will equal 4 square root of 2 over 3 times square root of 2 times itself, 2. Now simplify. 4 divide 2 equal 2. So this means 2 square root of 2 over 3. The denominator is 3, like which is required. Yes. So the numerator is
it's equal to square root of 2.
مستر بس يما حضرتك
Where
تعمل
is
تاني
that
بس
one?
طبعاً.
It's this result. Correct.
قصدك تعيد تاني بس.
Again. The question is given like that. The multiplicative inverse of this number equal number over 3. Okay. So now the multiplicative inverse of this one equals 4 over 3 square root of 2. Now simplify it and change the form by multiplying the number by square root of 2 over square root of 2. Numerator 4 square root of 2. Denominator 3 times 2. Now simplify 4 divide 2 equal 2. So 2 square root of 2 over 3. The denominator here is 3 and here is 3. So the numerator will be 2 square root of 2. Right? From the choices, it's this one. Okay?
Okay.
Okay.
Now, guys, is it clear?
Yes.
Yes.
Okay, great. The next question. Square root of 5 times 1 over square root of 5 times the square root of 5. Okay. Multiply the first two numbers. Square root of 5 over itself. 1 times the square root of 5. So square root of 5. Correct?
Correct.
Okay, the second one. Square root of 3 over 3 times 4 square root of 5 over 20 times 5 square root of 3 over square root of 5. Okay. Actually, guys, I prefer to simplify the numbers. So this means simply I can terminate 4 times 5. It's 20 with that 20. Am I correct till now?
Yeah.
Yeah.
Okay. And what about termination of square root of 5 and square root of 5? Also correct. So now, square root of 3 times square root of 3 over 3, which means 3 over 3. So 1. Done. Right?
Right.
Okay, guys, this question is also clear?
Okay, Mister, can you repeat it?
Yes,
Yes.
sure. Just to concentrate on the simplification. It's very easy. Numerator 4 times 5, 20. You can terminate it with that 20. Correct?
Correct.
Okay, then square root of 5 from the denominator and numerator. So also you can terminate them. Correct?
Correct.
Now, what will be the remaining terms? Square root of 3 times the square root of 3 over what will be the remaining term? Only 3. Square root of 3 times itself, 3 over 3 means 1. That's it. Okay?
Okay, Mister.
Okay. Now it's time for the last part in the lesson. It's about how to distribute multiplication on addition and subtraction. Actually, this one is very easy. We studied before in trip 1. Okay, it was like that. I'm going to multiply A times B plus C. So simply to solve this question, I'm going to multiply the element A times the remaining elements inside the bracket like that. A times B, AB plus A times C, AC. Done. If it was like that, A times B minus C, so it will be the same result, but the only difference here, A times B, AB minus A times C, AC. Right, guys?
Right.
Okay, so let's solve the numerical examples like that. Switch off your microphones, guys, please, so that we can concentrate very well. 2 square root of 3 times 5 square root of 3 minus 4. So simply, as I explained, by this one by this one, 2 times 5, it's a 10. Square root of 3 times itself, it's a 3. So here, 30, right? Minus This 1 times the second term. 2 times 4, it's 8 square root of 3. Can I simplify it? Of course, no. Now it's in the simplest form. Okay? This question is clear, guys? Huh?
Yes.
Yes, يا مستر.
ممكن بس حضرتك تقرا؟
Again. Just to multiply this term by the first term. 2 times 5, 10. Square root of 3 times itself, 3. 10 times 3 is 30. Minus 2 times 4, 8 square root of 3. Okay?
اوكي يا مستر.
Okay. Before solving the next question, I want to remind you with how to multiply by using the inspection. We studied that one on the prep one on the first term. Concentrate. X plus y all to the power 2 equal first term squared plus first times the second times 2. 2xy plus second term squared y squared. And if it's in case of x minus y to the power 2, it will be the same result, x squared 2xy plus y squared, but the only difference here in the sign. If it's a minus, so minus. If it's a plus, so plus. That's it. Okay? That was what we studied in prep 1. And also there is one more rule. If there is x plus y times x minus y, so in this case, it will equal the first term squared minus the second term squared. So that was the 3 main rules which we studied before. It's very important, actually. And also, it's mentioned in the book as a reminder like this. Okay?
Okay.
Okay. So now, let's apply these rules on our lesson. First, five square root of 3 minus 2 all to the power 2. So, as we said, first the term squared. Okay, this one is squared. 5 squared, 25. Square root of 3 squared, 3. So, 25 times 3, 75. Correct? Minus 2 times the first times the second. So 2 times this one times 2 again. So 2 times 5, 10 times 2, 20 square root of 3. Okay?
Can you say it
Okay.
again?
Again. It's a rule from the last year. Nothing new. A bracket to the power 2. Bracket to the power 2, first term to the power 2. Now, this one to the power 2, 5 squared, this one is squared. 5 squared, 25. This one is squared, 3. So 75. Okay?
Okay.
Okay, minus 2 times the first times the second. 2 times first times the second, 2 times this one. 10 square root of 3 times this one. 20 square root of 3. Correct? Plus second squared. So 2 squared means plus 4. Now simplify the like terms. 75 plus 4, it's a 79 minus 20 square root of 3. I'm done. Okay, guys?
Okay.
Okay.
Now this one is clear or not yet?
clear يا مستر.
مستر لو سمحت ممكن تعيد اللي هي ده plus second square root.
Plus the second squared, it's a 2. 2 squared means a 4, right?
Right.
Okay, now 75 plus 4, it's a 79. And then I just wrote this one as it is without any change because this one is totally different term. Okay?
Okay. Okay.
Okay, another question. If the question's like this, 7 square root of 2 minus 5 times 7 square root of 2 plus 5. Okay, it's a rule. We said that if it's x minus y times x plus y, so it's a first squared minus second squared. First squared, 49 times 2. So it will equal 98 minus second squared, 25. So simply this one will equal 73, right?
Right.
Now this one is also clear, guys?
Yes, Master.
Okay.
Mr.
Another
Can you repeat
question.
it?
Yes, sure. This question in the form of x minus y times x plus y, correct? So x minus y times x plus y means it's the first term squared minus the second squared. So first squared, 7 power 2, square root of 2 power 2. 49 times 2, 98, correct? Then minus second term squared, 5 squared, 25. So 98 minus 25, 73. Okay?
Okay.
Okay, another question. Two plus the square root of 3. Square root of 3 plus 7. Okay. To solve this question, just to multiply the first term by the two terms, 2 times this one, 2 times this one. So 2 square root of 3 plus 14. Are we okay till this point?
Yes,
Can
Master.
continue.
The second term times the first, the second term times the second. So 3 plus 7 square root of 3. Now it's time to add the like terms. 2 square root of 3, 7 square root of 3, 9 square root of 3 plus 14 plus 3, 17. I'm done. Clear?
مستر
Clear.
ممكن
Yes.
ترجع للصفحة اللي فاتت،
What's your question?
الصفحة اللي قبلها اللي هي the rule x squared minus y squared.
It was like that. X minus y times x plus y will equal first squared minus second squared. Okay?
Okay.
Which means the first term to the power 2 minus second term to the power 2. Okay, so this one is the first, this one is the second. Okay?
Okay.
Okay. Another question. But before that question, guys, do we have any questions? Any questions
Mr.
right
Mo,
now?
can you explain it again?
Which one?
This one.
The rule? It's a rule.
Yes.
X minus y times x plus y equal first squared minus second squared. It's a rule. Right?
Right.
Okay. So you just memorize it.
مستر طيب هي كانت الإجابة بتاعت اللي هي 2 plus 3 multiply 3 plus 7 دي كانت
9 square root of 3 plus 17. You mean to that question? You mean to this one too? Plus the square root of 3 times square root of 3 plus 7. Multiply this one by this one, and again by the second. 2 square root of 3 plus 14, and square root of 3 times itself, 3 square root of 3 times 7, 7 square root of 3. Now 2, 7, 9 square root of 3 plus 14 plus 3, 17. Done. Okay.
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 Okay. One more question. Here in this question, if x equal 5 square root of 3 minus 2, y equal 5 square root of 3, 5 first, plus 2. Find x squared plus 2xy plus y squared. Okay, how to solve this question? Now concentrate with me well. Okay, to solve this question, if we will check this expression, we will find that this one is x plus y to the power 2. So this means x 5 square root of 3 minus 2 plus y 5 square root of 3 plus 2 all to the power 2. Now simplify the terms. This one plus this one, it's 10 square root of 3, negative 2, positive 2, 0. So this means that this one to the power 2, which means 10 to the power 2, 100, square root of 3 to the power 2, 3. So it will equal 300. Okay, guys, this question is also clear?
Yes.
Yes.
Okay, another one like this question exactly. It's like that. X equal 2 square root of 3 minus 1. Y equal 2 square root of 3 plus 1. Find x squared minus 2xy plus y squared. Okay. Actually, this expression is x minus y all to the power 2. So x at 2 square root of 3 minus 1 minus y 2 square root of 3 plus 1 all to the power 2. Now guys, this one 2 square root of 3 minus 1 minus 2 square root of 3 minus 1, right? Because minus here and again here. So simply to simplify this terms, 2 square root of 3 minus 12, 0, negative 1 minus 1 equal, of course, this to the power 2, all of them. So it will equal negative 2 to the power 2, which means it will equal 4. Okay?
Sir, can you repeat this question?
Yes, sure. Again, guys, concentrate with me in this question. Actually, this expression in the form of x minus y all to the power 2, right? This one is x minus y to the power 2. So simply, this one will equal x to square root of 3 minus 1. Yes.
معلش ينفع نظبط المواعيد معلش.
Minus 2 square root of 3 plus 1. And this all to the power 2. Okay. Now it will equal 2 square root of 3 minus 1 minus 2 square root of 3 minus 1, because here minus this term and also minus this term to the power 2. Now 2 square root of 3 minus itself 0, negative 1 minus 1, negative 2 to the power 2. So equal 4. Now is it becomes clear, guys, or not yet?
Yes.
No, it's clear.
Okay, great. The last question in this lesson, okay, and concentrate very well on this one. Actually, it's about estimation.
Okay.
Give an estimation. For 5 plus the square root of 10 times 3 minus cubic root of 7. Then check your result by using the calculator. Okay. Actually, this question is very easy, and it's not exam questions, you know. Okay, so how to solve this question and how to get this estimation? Now, guys, 5, actually it's a 5, no estimation for 5 because it's a constant number. Then what about square root of 10? The nearest square root of 10 to the nearest square root for square root of 10, actually square root of 9. So now square root of 10 is 3 because square root of 9 equal 3. So now 5 plus square root of 10 equal 5 plus 3, which is equal 8. Okay? Then the next point, of course, we are going to get the estimation for what? For 3 or cubic root of 7? 3 fixed number. So cubic root of 7. So cubic root of 7 is 2, of course, because cubic root of 8 equal 2. So now 3 minus cubic root of 7 equal 3 minus 2, which means 1. So now this term equals 8. This term equals 1. So 8 times 1 equal 8. So that was the estimation. If I'm going to use the calculator to get the result, I will find that by using the calculator, the actual result will equal 8.873. So that's the question, and this is the solution, and actually it's not important. Okay? Okay, guys?
مستر يعني احنا نكتب في السؤال ال 8 لوحدها ولا ال 8.873؟
That one, the estimation. That one, the actual by the calculator. That's it. Okay? So it's 8 as estimation, 8 point something as actual result. So the estimation is accepted.
مستر يعني ايه estimation؟
Rounding. It's like approximating to get nearest result to the actual one. Okay?
Okay.
Okay. Okay, guys, any questions? Huh? Do we have any questions?
No.
Okay, guys, actually, that was the last question of this lesson. Hopefully, all of you understood every point in this lesson. Thank you for your time.